Hi guys, this video is going to be an introduction to parallel programming in Java. So the topics that we're going to discuss is what is parallel programming, what is the use, why use parallel programming, what are some examples of parallel programming, and finally, what are some disadvantages of parallel programming. So if you are a bit confused on this topic, feel free to watch the whole video because this will be a great learning experience for you and also for myself. So let's get into it. So as you see here, this is a great diagram describing what parallel programming does. Basically, you take a process and then you split it into two processes. So parallel programming is the practice of running multiple tasks at a time using multiple compute resources. Even though multiple compute resources are executing these asynchronous tasks, it's important to note that in most cases, every single one of those resources are being executed on the same CPU. Also note that these tasks are defined based on the function assigned to them, which is known as functional parallelism. Now let's get to why we need to use parallel programming. So there's a number of benefits to using parallel programming. Some of the primary ones include overcoming the maximum clock speed of processors. So basically, when processors have reached their maximum clock speed, we can't reach more processing power from that front. So we open a kind of new front by using parallelism. We can increase the productivity of the CPU by creating multiple threads. Then also we can use parallel processing in artificial intelligence. So parallel programming can increase the reaction time of autonomous self-driving cars to levels faster than the reaction time in most humans. So just to give some context, most humans have a reaction time of 0.25 seconds, so a quarter of a second. But most most programs or AI programs that use parallel programming can get the reaction time down to maybe a tenth of a second or even less. So it really helps in decreasing the reaction times. There's also things with LAN. So LAN is a networking concept, and basically it allows wide area networks to um, use their resources more effectively, and it also increased data limits on data storage. So anything storage related like AWS S3, any type of database, be it MongoDB, Cassandra DB, MySQL, it allows for greater database storage using parallelism. And it also increases the effective utilization of hardware resources. So basically, once you've run out of um, a processor, you can add multiple processors or cores, and you can achieve parallelism by creating multiple threads. So it's an effective way to maximize the use of your hardware. So now let's go on to some examples of parallelism in Java. So first we'll start off with the fork join framework. So let me pull that up here. Yeah, so the fork join framework is basically a framework that is designed, that is based on the idea of divide and conquer algorithms. This framework is basically split into two parts. So first there's the fork, and then there's a join. So the fork part consists of recursively breaking down the task into smaller and smaller components until the task can no longer be broken down any further, at which point it is being computed. So here's a nice diagram where the fork task is taking place. So it has a big problem. It's breaking it down smaller and smaller and smaller until it's indivisible. Then the process is solved, or the task is executed, and then it is joined back again to create a big solution, so to speak. It's not a solution in the traditional sense, but what we're doing is we're solving a lot of small problems and combining it using the join part or join method to get a final result at the end. So that's the fork join framework. Next, we have Java threads and processes. So threads and processes are basically a concept related to parallel programming in Java. So basically threads, which can be thought of as a series of executed statements, can run multiple tasks using by extending the thread class. Using this class, new types of threads can be created, such as user threads and daemon threads, which are the two basic types of threads. And you can think of user threads as basically high priority threads, while daemon threads are more low priority threads. And here we have an article detailing the difference between a thread and a process. So a thread is a subset or a unit of a process. So a process can have many threads and a thread can have many tasks. So basically that's like the hierarchy. And a compute engine or a CPU can have many processes. So that's how the hierarchy takes place. Next, let's move on to locks. So locks are basically um, a mechanism to protect against race conditions. If you don't know what those race conditions are, don't worry, I will explain them shortly. A race condition, actually, I will explain them right now, is a race condition is generally defined as a scenario where parallel execution of a Java program done by multiple threads at the same time causes concurrency issues in the form of inconsistent data from the use of shared objects. So here's an example of a race condition. So you have process P, and process P reads value 3 from the database, and then it stores the value V, which has the value of 3, in the database. Simultaneously, process P2 also reads the value 3 from the database, stores value in the form of variable 3 in the database, but then it increments the value of V by 1. So now it stores the value of 4 in the database. But unbeknownst to process 1 still thinks of V as having the value 3, even though that value was already incremented to 4. Process P1 is not aware of this. So when it calls V++, it's actually incrementing the old value, 3, which is not correct. And then it's storing the value 4 in the database, even though that value has already been stored. So this is the data inconsistency issue that is present in race conditions. And this is what Java locks want to, or that is the goal of Java locks. They want to prevent these race conditions by locking a resource or a shared code block so that only a single thread can execute that code block at that time, and any other threads that want access to that block will have to wait in a kind of blocking queue. So any other thread that wants to execute a certain code would have to be put in a blocking queue, and then in a first come first serve basis, once that lock's been released, those other threads will have access to the shared code block. So that's how locks work. And there's also many different types of locks, like reentrant locks, read-write locks, stamped locks. There's lots of different types of locks, which we won't go into in this video. But yeah, it's good knowledge to know what a general idea of what locks are. Next, we'll move on to the volatile keyword in Java. So the volatile keyword is basically a way to make variables thread safe. So in case you're wondering what thread safety is, it's basically the idea of being able to share a code block in concurrent and multi-threaded environments. So uh, to give an example for this, let's go through an example. Um, in Let me pull up my blog here. So in this example, we can see a class called running shoe, and it has some fields. And the value assigned to the shoe type variable uh, is the value assigned to the shoe type variable, which is this one, uh, also has the volatile keyword attached. So, well, for all other variables written in memory. So basically, whenever you assign a value to the shoe type variable, all other values that all other variables have will be written to main memory. If we extend this example, so that's basically what volatile does under the hood. So a bit of a complex example, but basically whenever a volatile variable is assigned a value, all other variables that it has access to, uh, those variables' values will be stored in main memory instead of being cached. And this is done in order to keep updated copies and prevent data inconsistency issues similar to the ones you saw in race conditions. And in case you're wondering what main memory is, that's basically RAM. And um, here is a nice graph showing what this architecture looks like. So you can see RAM, that's main memory, and then there's caches. So basically, when you declare volatile, all your other variables that that volatile variable has scope to will be stored in main memory instead of the cache, which makes it slower, but it eliminates the data inconsistency and race conditions and the host of other issues that can occur if volatile keyword is not used. So that's basically some examples of parallel programming in Java. There's many more, but for the sake of this introductory video, we'll conclude it there. So next up is the disadvantages of parallel programming. So there are a number of disadvantages for parallel programming, namely it's because systems that use parallel programming can be complex to design and very design intensive in the initial phase of starting the project. And also parallel programming can cause many concurrency issues such as race conditions, deadlocks, and memory inconsistency issues. So let's go over these issues that are related to parallel programming. So first up is the race condition. So we've already covered this. So basically, it's basically saying like the if it occurs as a result of parallel execution of a program by multiple threads. So I think this example should suffice for now. So let's move on to deadlocks. So deadlocks are kind of related to race conditions, but not the same thing. And deadlocks occur from when two threads sharing the same resource prevent each other from accessing the resource that they want to obtain. This results in both threads indefinitely waiting for the other thread to unlock their resource in order to gain access to that resource. But that thread will never unlock that resource because it's waiting for the initial thread to unlock their own resource. So it's like a deadlock or stalemate condition where in which a conclusion will never arise. So let's give an example to this. So if thread A gains access to resource A and thread B gains access to resource B, then a brief moment later, when thread A attempts to gain access to resource B, It can only do so when the resource B has been released by thread B. So in the same time, thread B also tries to access resource A once thread A releases the lock on resource A. And this is the problem. Each thread is waiting for the other to release their own lock on the resources that they currently own in order to access the resource that they currently don't have access to. So that's the deadlock dilemma. And it's visualized through this picture right here. It's like you have a thread and it's waiting for resource one, but resource one is owned by thread two and it's waiting for resource two, which is owned by thread one, and it'll just go on and on. So a solution to this might be to implement a timeout function or method where in which once a deadlock has been detected, say let's after 2 or 3 seconds of having detected a deadlock, immediately kill both threads. So basically, that'll eliminate the deadlock condition, and then we can choose to restart the threads if we so wish. Um, Also, as a final note, disadvantages of parallel programming could also include like a higher average power consumption from a hardware perspective because you're using the hardware to its maximum capabilities. So it makes sense that the power that hardware requires would increase as well. And when also as a final note, another disadvantage would be when you're scaling the parallelism or parallel programming and you're scaling for multiple and multiple and multiple threads. It can get expensive if you're using a infrastructure as code service like AWS, DigitalOcean, or GCP, Azure. It can get expensive in terms of the number of increased data transfers, synchronization attempts, communication, and thread management attempts. It can get really costly. So that could also be a disadvantage. So that basically concludes my introductory video on parallel programming. Hope it was helpful. I know it was helpful for me because I learned a lot in the researching of this and learned a lot through basically learning in public so that I can teach my knowledge and share my knowledge with the world. Um, so thanks again for watching my video. If you would like to access my blog post for this video that corresponds to the video, I'll link to it in the description. And if you found it helpful, please make sure to like and subscribe. And if you have any criticisms or things that I can do better, please let me know in the comments below. And that's it for this video. See you guys in the next video.